So Eva had already just helped me introduce myself, and I'm gonna talk about the accountants directly. And firstly, I still like to talk a little bit about myself with you, maybe just for connection and what kind of communication, if you like. And I had a bachelor's degree in mechanical engineering and automation design. And then during the gap year, I did not know what I want to do in the future. And also, as you might have studied engineering, you might know that as a female, when you enter engineering, there are just lots of barriers, or you just don't know, you're just not sure what you're going to do or how you can be successful in related fields. So I made the great decision, I have to say. I went to recruitment consultancy to be able to see a great range of industries and job professions, so which suit me best. I still had a problem during the stage. And after 1 year, I was so lucky to be admitted into the Master of Science Engineering curriculum at UCL. I'm still really appreciate all the help and support I have received from Professor Abel J and Professor David Guile for all the kindness offered, because I've never tried something so hard to be admitted into a dream program. I think it just enlightened me with all the inspirations and passion for engineering education. And it was also the first time that I felt myself intrinsically motivated about learning something. I do not want to say that it is so much life-changing, but admittedly, it had impacted my career and my life very much. So following the program, after graduation, I joined UNESCO-ICHEI as the program officer for curriculum development. And all of the knowledge and skills and competencies I have acquired from this program had now benefited me to go further. So I would now refer to myself as an academic practitioner, just as inspired by Abel, solving problems in education as an engineer. Now I will begin my presentation. So today we just involve 3 parts. First of all is the emerging technologies in higher education. And second, the implications for engineering education. And third, empowering teachers for a digital future. Let's come to the first part. I don't know if you have any general knowledge about AI, but thinking about AI in higher education, we might want to return to the departure point of how it works. So AI, it is defined as theories and techniques developed to allow computers system to perform tasks normally requiring human or biological intelligence. But AI as a concept and integration of technologies is generally framed down to the 3 components I have added here: artificial intelligence itself, machine learning, and deep learning. So deep learning is a type of machine learning, and they are all subsets of artificial intelligence. Machine learning is about computers being able to think and act with less human intervention, and deep learning is about computers learning to think using the models based on human brain, so it can continue to work and solve problems with less and less ongoing human intervention. So technically, let's say that deep learning can analyze images, videos, and unstructured data in ways that machine learning can't easily do. And to make a little stop that I'm actually not an expert in AI or big data. I have not studied related programs systematically, but just as many of you, we are the social scientists, maybe in future. So today we are probing all the potential possibilities from a perspective of social science, or what we say the professional practice of engineering education. So I will continue with what I have explained about AI. And so we can see now there are generally 2 trends: narrow AI or general AI. And there's also thinking about the super AI. which is as much advanced as you can imagine. The reality is actually still far from the conception, because the conception actually originated in 1950s. The imagination can always go really wide. And all the AI we use today are narrow AI, which means that they are created to solve specific problems. For example, a chatbot. And general AI just refers to all AI technologies that can be utilized comprehensively in solving any domains with any problems that require these technologies. Although it has not been fulfilled, the advancements are just accelerating. So how AI can be transformed and applied in higher education? I've listed a few of the examples. So first of all, the search engines. For example, those have been used in digital libraries. It just tracking like learner behavior and intended study fields to help them just target needed resources more effectively. And based on that, the intelligent recommendation systems, I suppose many of you have experience of studying MOOCs. And now many platforms, it just offers the intelligent learning path that suits your needs and capacity, and just collects your data of your search engines and your behavior and the time you have stayed on specific courses to predict, okay, that's the courses you need, and you help you advance your learning in the most efficient way. So let's say the recommendation systems is where the AI are commonly used. And then the self-adaptive learning system for the LMS, I can see an example that is the Squirrel AI Institution in China. Maybe if you're Chinese students, you might be familiar about it. I'm not sure about outcomes effects, if they are good or bad with any reputation, but from the practical examples, they have set up the systems that help evaluate students, especially in examinations about their test scores, and then the system, the AI technologies will be able to capture this data and find out, okay, that's the deficiencies of your to test your learning weakness points or deficiencies to help you critically and efficiently improve your test results. So that's for the LMS. And the LMS is also reciprocal. It captures students' data, and it just helps the teachers engage with students better in other ways. And integration with VR and AR, I think that requires very much investments into this field. I think many tech companies, they are having some good combinations like AR and 5G to do this simulation. For example, engineering education, they can simulate a project or a production process in a factory to be real-time display for engineering students just in classrooms, and it just help them establish a better understanding cognitively through this combination of technologies, which is also very intuitive as well. And the virtual assistants, I think we're all very familiar with it, like the Siri or something, but it just can be simply reapplied in many different contexts. And for language translation, grammar check, we're so familiar with it in our everyday learning, the Grammarly, or just as the PPT design functionalities. And for facial recognition and image labeling, I think this is one of the concepts of the forming the digital institution, but there's yet there are many arguments about it in terms of privacy or whether we should insert so much control on students' learning behavior, making the class not so lively, but just like production mill or something. But it's still very good. A lot of innovations based on the AI and what it can do to help us promote a better level of digital transformation. I'm going to talk about the frameworks and analysis of the AI application higher education. So by this side, I would firstly like to show that this is the result of the human and machine image recognition competition. One of the most reputable competition in this field, sponsored by Stanford University, Princeton, Google, and another company called A9. So we can see that red line stands for the error rate of a trained human annotator, which remained at around 5.1% across the 5 years from 2011 to 15. And for that of AI, you can see the error rate increasingly went down from 25% to less than 4.8% in 2015. Though that due to study limitations, there's no specific evidence showing that AI can really outperform human beings in image recognition at every level. But there is just a clear trend that AI develops progressively with significant improvement on decisioning. So AI in higher education, are there any trends as well? I've quoted this framework. It was in a report of the AI, a report of the ICHEI report, I remember, and it refers to the AI education maturity model. And in the first stage, we are approaching and understanding these technologies. It's still in a stage of conceptions, imaginations, and secondly, well, imagination never stops though. And the secondly, to experimenting and exploring. And I suppose for my country, in China, we're pretty much at this stage. There are many tech companies and fundings from the government, from the country, from the institutions, and they are just investing in just like digital and ICT infrastructure without thinking on the cost. I think the train was very wild for some reasons at the current stage, especially during the COVID-19 crisis. And we are eager, desperate to think of, okay, what would be the future would be waiting us in AI, how AI and or big data would be supportive to combat the current crisis in who knows what's possible in the future. So experimenting, exploring, and there just can be a lot of useful or unuseful technologies during this stage. And then operational, it is then that AI will be used for one or more processes across an organization. For example, chatbots, it is mature, but for other technologies like the LMS, most of them are still under exploration because it just is a matter to do with all the data, how you categorize the data, and how you just enhance the capacity of the AI to intuitively adapt to your needs. And that still requires a lot of work on how we improve the algorithms and so on. So, and then embedded, I think I have not done a lot of research about AI applications in this field, as we have not gone that far. But during this stage, it says that many of the processes related with AI will be already standardized and functionalized or practiced for prior experiences and for better improvement. And then transformational. Then the transformational, it will be the state that we have comprehensive understanding about what is the digital compass and how this digital technology can just form together as a infrastructure or a basis to support every of the teaching, learning, self-study activities interconnected with each other. And following that, and coming down to the curriculum side, although I think we should look far into the future, but also coming back to what our professional research lies down to the curriculums about higher education training for AI. So for this one, we can also look for examples as well. I would like to share a case study in China as I'm more familiar with the context. So the program was established in 2019. I'm going to make it a blind case, but I hope that the information will be useful for you all. So this is one of the most leading undergraduate AI programs in China. And I'm going to talk about it starting from the admission. You might have heard about the Chinese College Entrance Examination, CCEE. They test Chinese students, Chinese, math, in English as compulsory courses, in arts, science as the selectives. I would say it's a life-changing examination for the great majority of Chinese students, as it can be the lone criterion for admission into most Chinese universities. So in summary, CCEE is a selection across the country and is strongly connected to students' learning and understanding of theories or even their memories. And for this program, absolutely, they recruit the best of the best, particularly those showing extraordinary talents in math, data science, and other kinds of scientific breakthroughs. You might find these students usually have successful track records in winning the medals of international Olympic math competition or programming contest, but they are genius or half genius as well. So that's for the admission part. You see, the gate is very high. I mean, for this level of AI programs, because they really invest a lot into whatever the faculties or curriculum development. So it's fair. And in terms of the curriculum design, it is straightforward design for industrial applications, placing itself for international level AI competition at the frontier. So for the faculties, the courses will be taught by a group of frontline, like a researcher or industry experts with reputation nationally or internationally. And it is interesting to mention that all courses will be lectured in English. So have you thought about the question? So why English will be the instructional language for many engineering courses, I would say, or especially those related with the construction of AI algorithms or data sciences? That's just because, I don't know, but from my own perspective, I suppose that is the strong connection with the linguistics, like how the data algorithms are built, following what kind of logics they are referring to. So I think it is one of the small evidences I found, okay, they are realizing how language or the linguistics as a profession itself is important for AI courses. Okay, and the most significant characteristics of the curriculum are broadly introduced knowledge, mastery level foundations, and cross-disciplinary supervised. I know it sounds really difficult, right? But I think that's another aspect of the education in China. You squeeze the talents in to see whether they can outperform themselves. Just again, to the end, it's a selection-based curriculum, but yeah, as well, it just offers flexibility for you to study, for you to find yourself as well. But there are just more space and rooms for those who are really interested in this study and who are just the ones for it. Okay, so the main objectives are, I found there are 4 focuses. That is how to build stronger AI, bottlenecks for AI research and technology application, such as the NLP, self-driving, and third is a core chip making manufacturer of artificial intelligence technology, and then and following it is the novel statistical models. So there are also project-based learning embedded in the curriculum, which are generally based on like interdisciplinary challenges in AI. I have to study, however, you still might see that this program what we see different from the Western understandings of engineering education is that it is still plays a lot of on theoretical learning at a comparative high level, especially at the start of the learning stage. which can be quite different from what accepted in Western views. I have studied the Master of Science Engineering Education at UCL, being very impressed at PBL to be implemented at the ever start of the learning stage. I think you all might have heard about how PBL can be used for its best outcomes, but it's just different for many curriculums in China. So, however, what I have observed, just as I mentioned, the CCE has a great impact on the overall design, curriculum design, connecting high school students to university level learning. It just cannot be neglected. Lots of Chinese students are taught about theories in their previous learning routes, and they are therefore better at understanding theories. Or you can say they can better innovate on theoretical or abstract level. It just coheres with the progression of engineering curriculums. That engineering, even in top tier like universities, you tend to be more conservative in embracing full PBL, intervening early studies, just to make sure that engineering students, they are not too much self-frustrated, facing a huge gap between theory and practice. So in another word, I think theories might be considered in the same way as the stimulating problems in PBL, just to keep students going, to make them feel, I can learn it, I can master it, everything is in control. And with them continually increasing aspiration to apply this advanced knowledge in future when everything is ready. We're ready. So I'm not going to make any argumentation here about which would be a better replacement. So PBL is also popular here. There's a trend that more universities adopt this as early as they can. They are just aware of the gaps between theory and practice, which is hard to manage. And PBL just seems to be the antidote. Okay, so for this program, you can see they focus on the right side, like many fields in the first 2 years. They are encouraged to achieve the greatest intensity of advanced knowledge that undergraduate students can usually achieve in 4 years. So they are squeezing it into 2 years, technically. And in the last 2 years, the program will encourage students to have more opportunities like cooperating with professors from cross-disciplinary departments and to make meaningful applications of AI. And what to mention about is the internship or apprenticeship or professional work experience. They will have a chance probably to work in top institutions, and they are offered with the full funding, 100% funding for international exchange and scholarly mobilities. Quite another way of student-centered learning, isn't it? Okay, so that's for this AI program. And secondly, for the big data, the definition of big data is that it contains like great variety and arriving like in increasing volumes and with more velocity. And this is also referred to the 3 V's. And the big data technologies just can review the insights from data sets that are like diverse, complex, and from a massive scale. And here is a McKinsey Global Institute report. I have just got this information that there are 3 important elements about big data. First one is the techniques, just that the A/B testing, cluster analysis, crowdsourcing, and then there's the technologies more related to the context which they can be applied, like business intelligence, cloud computing, databases, maybe digital twin as well. And then the visualization, such as the charts, graphs, and other displays of the data. It's in 3 major fields. And so data has an application just in the variety of industries. You might have heard that business executives, medical practitioners, for example, in the COVID-19, they use the big data algorithm to predict what will happen in the future. Is it going to be, are we all going to face a higher risk going outside? Or what is a better decision like for international transport travels, and also for advertising. Governments who they regularly like meet difficulties with large sets of data in areas including like fintech, healthcare, analytics, graphics, information systems, and also in some science fields like genomics, kinetomics, in complex like physics simulations, like what I mentioned about the digital twin, and biology, environmental research, etc. In terms of education, so what can big data do, especially in higher education? Well, I say it can do a lot of things, but I would especially like to mention that big data does not only serve the students for better needs, but also providing like new metrics, analyzing, telling us what is good education, or the criterions like identifying what are the bad ones. So currently there are like common applications use the open source big data learning platform for students to practice and conduct data simulations as a virtual or distant laboratories and learning evaluation. It's like it can just predict any kind of the failure that is likely to happen before it really happens, and just make a meaningful impact on your studies and for your teachers to better supervise you in the resource allocation and curriculum design. So it can identify the like possible frustrations in the curriculum or administration process for teachers to better collaborate with each other, and quality assurance. So quality assurance is just like the real-time observation or intervention for learning, allowing like more flexible teacher interventions. And smart administration system, I think it is more connected to how digitized the campus has been built up with the technologies, so it can then just realize with these functions. I would also like to show a few of the like the examples. You can see that. Sorry. Okay. I'd also like to show a few of the example. So we have mentioned about the real-time observation and administration system. I think it will be a good example. That is when I visited a like technical school in China, and the at industry like university industry partnership forum, and there was a showcase, or you can say a pilot project for the school to implement a full like data big data based analysis system to record students like entrance or leave for school, because it was during a special stage of the COVID, and they need to test that who are the students, they are from high risk regions, and when they come into the school, and how the university can support them better to send them to medical services or to have them just get into the quarantine process, and how they are affecting other students, and the value of the students where they are traveling, if they would like to aid their data as well. So it just help kept the campus more safe. I hope it's a good example. And another one I would like to show, sorry, video. That is the IoT one. I wonder if you can see the video, but this one is actually when big data and the Internet of Things in education work in conjunction. Okay, so the IoT, like everything about the classroom and the like university facilities, when they are interconnected with each other, and they are able to like produce a lot of unstructured data to be recorded into the to be recorded into the big data system. And I think it will be applied for like school administrators. They can better see what is happening within the campus and if there are any like fires happening, so they will be able to help. And following that, I can share about the frameworks and pathways of application. Like what we have traditionally rely on the education was the theory-driven approach to construct a learning capacity and to test if the results are valuable, reliable, or replicable. And that's how we see the world. And such methods are deeply rooted with interpretivism, critical realism at epistemological level. And in terms of learning sciences or psychology, we refer to those as behaviorism and constructivism, cognitivism, and so on. So therefore, we have the testable hypothesis. We keep in mind that we know like experience to continue with the question to prove it and adjust the solutions. But in the future, let's imagine that for big data higher education with various tools of data mining, modeling, network analysis, machine learning, it just promotes us to think one step ahead, or to say the results are connected with the solutions in a more transparent way, showing the relationships in different factors that we are within control, so we can always make changes and improvements to make sure we are on the right track. I would argue that neither is sufficient, and just don't forget that data can lie as well. We need to approach like learning and innovation from both directions to do testable hypotheses on what we know and look for patterns in the data to lead us to think things we haven't thought of before. And that's improving a lot of things, like including goal setting, objective design, time management, evaluation, and so on. And following that, there's a big data curriculum. You can see the numbers of the curriculum. Big data is generally like more widely accepted than those of AI. And for the three major types, data science, and the types of degrees, because big data compared to AI is more like a methodology that can be recontextualized in different like industrial settings. So the three major types of degrees, the big data and science is first one is a management. It's a science degree, Bachelor of Science, and second one is a management degree, and third one it is of the mathematics side. So this is a curriculum. Case in China, you can see that the program adopts a combined teaching approach for management theories and practical application of big data. Similar to that of AI, you can see still, I think it is like a trend or something for many Chinese science or engineering programs. The first 2 years pretty much founded on advanced theories, especially math, physics, just to it feels to me like these are the raw materials that can make future projects more effective. So I'm not going to go through the details of this curriculum, but just to mention that it would just help you develop the breadth and depth of knowledge step by step based on just what they have innovated on lecture-based learning is that they made it expert panels. Maybe the traditional lectures are way too boring, and they have invited researchers or industry experts to introduce students what they are, or what is happening every day out of their textbook and comfort zone, so they can just feel like more easily to adapt to theoretical learning, maybe at the initial learning stage. And so for all the 4 years throughout the program, theoretical learning is placed on a high level. And for the last 2 years, we have projects, and they have more focus on designing the scenarios. And they have different types of applications for students choose their favorites or interests. For example, big data management and web development, applied statistics, logistics, operation analysis, healthcare, fintech. And you can just choose the project teams that are designed for you, and they're supervised conduct any kind of like peer studies. And let's come into the second part, implications for engineering education. Well, I can't answer this question, but it's a big question, right? But just as a learner, I think it would be valuable if we can just propose some question to see what kind of changes are we leading to in the age of AI. The first one would be, so is there any need for PBL to be placed at an advanced level? So let's say AI are put into the process of learning, or more human AI interactions, more factors, more distractions, more innovation, more problems. So I think first of all, there's a need to design the environment more thoughtfully. Like AI can create this functional environment with revenge effects, such as technology that hinders students' ability to stay on task. And we can see that's a PBL learning cycle proposed by Cindy. And so AI technologies can be quite different from existing ones, right? From within they can always respond to us and adapt to our needs. So there is a possibility that students' learning cycle engineering might be accordingly lengthened by getting to know a broader range of AI technologies that inspire them. So it's harder to manage it. And secondly, just be more critical on problem solving. So I've always wondered, once we have opened the Pandora box, are we solving the problems or are we creating more problems? So I think we should be more critical on problem solving in problem itself, how to say, and the third one, I'll just directly move on to the third one, as the time is very limited, is to enhance afterward peer evaluation. So many solutions are effective or beneficial on a larger scale, but in PBL, with the promotion of individually meaningful space, a variety of solutions are often appreciated. However, do we get a chance to talk about the risks? We know that potential of AI is great, but the risk is that AI is also a double sword. It's commonly known among many AI engineers that there is just an ethical line we cannot come across, no matter how beneficial it can be. So is the solution cost effective? Is it ethical? Does it have any environmental harms? Is it designed to contribute to human society? Or in other words, is it human-centered designed? I do think that peer review and reflections after the major PBL works deserve more time and consideration. And through this, we also engage students to be professional language in the new era, and critical thinking about ethics, identity, and society as a whole. And question 2, so what's beyond the project? I think compared with the project, what inspires me mostly is about experience, which is very powerful learning, because it's not only engaged with the conscious level, but also your subconsciousness, what is happening around you. You might not have time to analyze it, but the AI and technologies will influence the way of how you think. So we might think about what will happen in the digitalized environment, what types of knowledge and experience will be generated, and how are they related to big data and AI technologies, and how does it contribute to engineering, learning, innovation, and in what ways? And here's a framework I used to build, like integrating Nicole's work, the EXL model, experiential learning model, and a kind of innovation model, that is the ICHEI, knowledge, technology, technology, and the doing and experimenting model. So we can see that just a lot of the functions between different factors, and ICT tools will reshape the overall environment about how these factors are interrelating and impacting each other, and following different consequences. And the question 3, like what is next for the aim of design? Let me just show a picture. You can see the first one is the buildings in the second industrial phase, and the next one is the 4th stage of the departments today. So I'm thinking of, is there a need to for nature and technology to be integrated, especially for engineering students. We are now having the new objectives of COP26. We are considering sustainable development, how it can be better embedded into the curriculum. And secondly, considering human-centered technology design. I think it is important to analyze more deeply into the social science and the structure for societies operating as a whole. So what is the role of AI, how it should be placed? Is it designed to challenge our capabilities or to support our, it's like human, like technology or AI augmented learning and innovation? We really need to think about it and also think about the risk or the gates not to cross the line. So what are they? It just requires more energy to find out. And a third one is the generation of new jobs. And before that, we're always thinking of design-based learning with designing products. But beyond that, what's beyond the products? Are we giving enough consideration to the whole ecosystem? Are we AI immensely reduces a lot of jobs are diminishing, but if we will just be more active to look at the other sides, how AI, how human potential can be unleashed, creating new meaningful jobs on the basis of AI. And I think that's also a meaningful field to explore. And coming to the third part, and I've almost finished my presentation. And this part is basically based on my own professional experience, empowering teachers for a digital future, where we just talk about a lot about the futures and perspectives about AI, and we barely have a chance to look at how we can really get everything started. Where we rely on teachers to impart the essential knowledge, skills, and capacities, competencies for students facing the digital future. The teacher themselves or teaching as a profession itself has long been undervalued. So I'm looking at the digital gap. So how far are we from these overarching goals? I think it kind of just, because I work in international organization, it gives me opportunity to oversee a greater landscape, how these technologies have been accepted in different regions, and where are the difficulties they face. You know, we have some smart classroom projects, but in some like African regions or West Asia, those least developing countries, they want to implement the ICT resources, but they don't even sometimes have the electricity or water to support the essential conditions for they to start digital learning. So that's a big challenge, and teacher education as a main focus. So when we look back to teacher education, it may be the most efficient and beneficial, rewarding approach as a leading one. There are usually some reasons short of ICT equipment, short of teaching resources, professional instructional community support. Here are the works I do with my organization. We have the webinars and online courses and training programs for teachers to enhance the ICT and digital skills, and especially the digital literacy, about how AI, big data will have a future in higher education. And here are the three main sections: OBTL, that is online blended learning at the front, and then for leaders, decision makers, policymakers, they need to discuss about the agreements about the higher education digital future, and then especially for STEM subjects, engineering education as well. And also offering some additional resources such as the evaluation tools. However, we also do some research. I have been fully engaged in this project. I utilize all the knowledge I have learned from the Master of Science program, and I led this project about to just deliver to research and deliver the higher education, the competency framework for the higher education workforces. Well, maybe it's a very good summary of what I've learned throughout the Master of Science Engineering program. So you can see the horizontal and Okay, they are double size in including a lot of learning sciences taxonomies like Bloom taxonomy, knowledge management models. And then you can see some of the work we do. And I would especially like to mention about, because today is engineering, is about higher education in AI or big data engineering. I would like to especially mention about and express my sincere thanks to our course leaders and program directors. We have organized the IOE Global Webinar about engineering education as a special series. You can see Ebo there and Jay have delivered the learning and innovation session. And to continue, we will be very lucky to have Professor David Guile and the final session as female in engineering education. Engineering education, I would believe that it is the heart of the digital transformation today. So the final part, it would be, I think if you are students trying to apply for the Master of Science program, you might be interested in this page, because this is what I have chosen for my Master of Science courses. It's not a recommendation, just my own experiences and how it has benefited me to go further and apply all the knowledge and skills I have received from this program, and to continue my work. It's another stage of life in my professional work. Okay, so finally, I would like to quote a sentence from Bill Gates. So most people overestimate what they can achieve in a year and underestimate what they can achieve in 10 years. I think it could be like similarly applied in engineering education. So finally, the past and current systems should not limit our imagination of what is good engineering education in the age of AI. I just look forward to discovering, embracing, and changing all the possibilities with you all in engineering education and in our continued lifelong studies. Thank you.
Oh, thank you, Lan Yang.
Sorry about the time. I have some difficulty managing the time.
Yes, but
that's my contact information.
I really enjoyed it. I think I was looking at, we do have some of our students here, and some who are thinking of doing the MSc, and with some academics from UCL as well.
Okay.
I was really looking at AI, how it is advancing. Of course, I do know quite a little bit, but I never quite anticipated the amount of change that is currently taking place, and that you are actually at the forefront of applying or thinking about how AI can actually be utilized to deliver education. My question is always this one: when it comes to AI, is there any chance that individuals like myself, educators, might actually be replaced and the students just engage with the AI system? What are your thoughts on that?
Well, that's the ultimate question, isn't it? So at the end of the tracks, the running tracks, so this side human, this side AI, so who will win? That's the question we all care about, especially in education. So what would be your answer? I think everyone will be aware of that, and we hope that teachers will not be replaced. So why? I think first of all, from the technical level, we have mentioned in the presentation that AI, its capacity is about, like, for example, image recognition. It's great and it's like crazily increasing. It seems to outperform humans, but it's only about yes or no. It's about they are making the decisions very fast. But for humans, I think we also discussed this very meaningful problem in one of our master science courses. Is that humans we always have the uncertainties kept in our minds to allow for possibilities and to generate like opportunities that are never likely to happen, but all the things just came out to be a surprise. But also as human, innovation, we may not be able to reframe innovation, but we will be able to like the care and tangential support and individualized learning plans for the students, not only from the data or not only looking at data or technological side, but from our hearts, and to exchange shoes, or to just draw our own experiences. I think, yeah, AI is good, right? It can predict the future, but it just do not have the certain experiences to be impressed in a certain way to motivate students, inspire students. So I think that is one of the those of the great values that the teachers can do in engineering. And also, I think in the future, engineering, it is a technology at first and also now, but in the future, there is a trend that engineering is more and more related to nature, to philosophy, to education itself, to humanism, to ethics. And that is the right age for human teachers to be more professionalized, to be upgraded, and using better AI just as a tool for education to advanced learning and teaching and learning. Thank you.
There's also a question from Chan Chuan Ji. He says, as a computer major student, is it a good option to courses? You were talking about the case study, which is recruiting the best students for university, and then they are studying university courses. What I'm going to do is I'm going to allow Chan Chu to talk, so that the question is not quite clear, and then we hear from, I suppose it's a yeah.
Yes,
Chan Chu, can you go ahead with your question?
Hello, Chan Chu.
I have enabled you to speak.
Yes, Chen Chen, you're muted.
Just unmute, ask to unmute.
Yes.
Are you able to unmute and to talk?
I'm not unable. I'm not able to unmute.
I've tried to unmute.
Oh, she said Chen Chen say doesn't have the microphone. Or,
okay.
Yeah.
So I think she was just asking, as a computer major student, is it a good option to pursue? I think she might have been talking about the program you were talking about in China, the AI program. What do you think about it? Is it a good program for students to pursue in China?
Okay. Thank you, Chen Chen. Maybe I would like to, I hope to see more of your elaboration on this problem. Are you talking about the course, when you see the courses, are you referring to the Master Science Program at UCL, or you want to talk about the curriculums, AI or big data curriculums in China, typical cases?
Just to type it on the chat.
Yeah, just type it for us, please. Maybe I can start talking about something related to UCL program first. If Chen Chen will have further questions, we will address on that. Yeah, because if we are going to talk about the UCL program, I think a lot of the audiences today will be interested in this program. Well, I would say if you are a computer science student, or any other engineering subject students, if you want to apply for this program, you have to consider following questions. First of all, what do you want to achieve? Let's say if you're still passionately interested about technologies, or you want to be a scientist or something in the future, it will be a good option, but it's not a destination. It will help you. It will help you just develop more sensitiveness about how you can learn a science program, engineering or computer science. It will also help you broaden your horizon about what is happening in the future. And so, if you were an engineering if you were engineering students in our undergraduate studies, if you attend this course, and you will be able to look at engineering from a social science perspective, and even further, you will be able, you will gain the capacities of metacognitive skills to plan your learning better, and you will know, you will learn about how to learn engineering. I think that is quite important. So it's like, if you still want to focus on engineering and you want to apply for this program, I think it will foster all of your learning capacities as a whole, and to help you achieve better in your future program, still in the fields of engineering. But if you, like me, you're confused about your future in engineering, or you face like any kind of obstacles in current job market, or you're just uncertain about your professional development, thinking, oh, my characteristics and personalities do not fit into the engineering. I do not like to deal with the engineering problems. If you're like me, you can give yourself a chance to try if this program fits your expectations. Don't set expectations too high. But I think if you have interest in psychology, especially in psychology, learning sciences, and you have a care for others, you can, because if you can just switch your roles, it will be, I suppose from my experience, it will be easier for you to accept the core philosophies and the strategies introduced in this program, such as the PBL, because it's student-centered, and you need to just have a good foundation yourself to connect your own characteristics, your potential. Because following this program, if you want to be a social scientist, you might hope to develop their potential in social science research. So you better, like, you enjoy reading, you enjoy learning about psychology, and also don't forget that don't throw away your intrinsic passion about technology. And if you're a sci-fi lover, I think absolutely you will benefit so much from this program, and you will enjoy it very much. And that's my answer.
I learned. Okay, thank you for promoting the program. But I still remember the many arguments we used to have because it was free, the COVID pandemic era. And I'm so pleased that you accepted to become our very first speaker in our very first MSc Engineering and Education Colloquium. And it's a very strong topic because AI is currently at the forefront of everything. And it's so nice and pleasing that we have one of our own who is actually developing strategies, championing those strategies, and training other engineering educators worldwide to master the technologies. And I would, on behalf of my colleagues who are teaching on the MSc, I would also like to thank everyone who came today, and to remind you again that tomorrow at 12 o'clock, we are going to have another one of our students. That's Sama El Sayed. She is still a student. She hasn't yet graduated, but she is already developing education training curriculum for people in the renewable energy industries in the, I think it's in the United Arab Emirates. So we would like to welcome you again to be with us tomorrow to see how people are actually utilizing their knowledge of engineering education to deal with pressing issues facing engineering education in very different contexts. And Hope you have a lovely day. Thank you, everyone. We slightly overshot, but I think it was well worth it. Also, on that regard, I'll bring this show to a close. Thank you.
Thank you so much. Thank you, Abel. Thank you, everyone.
Thank you.
And I have sent my contact email if you would like to be connections or if you have problems or queries. I would like to answer that.
Yes. So the email link is in the chat, and if you haven't taken it and you want it, just send me an email and I can give you Lan Yang's details.
Yes.
So on that note, you have a good day, and thank you everyone for coming. Bye-bye.
Thank you. Goodbye. Have a good day and good night.